Okay, welcome back everyone, for real this time. Announcements for this week, we have a meeting, again next week of course. We'll be doing a case study. We'll be looking at some I didn't finish writing that. We'll be looking at like a couple examples of like some good game design within games. Then also we have the Game Jam coming up April 11th. To the 13th in Marston 2300, starting at 7 p.m. I encourage everyone to go. So we have game night this Friday, 7 p.m. to 11 p.m. on Discord. Make sure to go vote for whatever game you want to play out of the options on there. So should be fun. And if you're interested in paying dues, make sure to do those. Ethan's here, of course, today. So and we'll be helping out with the shader workshop, or hosting the shader workshop, I should say. All right, it's time for your fun time.
Shaders, you know them, you love them. They can take your game, like Minecraft, and make them awesome.
Also kill your performance of Minecraft.
Exactly. So, I'm going to start off by explaining what a shader is for people listening on YouTube, or people here, what a shader is. So essentially, a shader is just a program that tells your computer how to render pixels to your screen. It takes objects like this sphere, takes the vertexes, places them, turns them into pixels, and then colors those pixels and displays them to your screen. This is a little overview of the whole process. As you can see, the element array is essentially an array that holds all of the values, the locations of all the vertexes. And then there's two different shaders in part of the render pipeline. There's a vertex shader, which takes those points, and depending on what the shader does, it may move those points around or modify them to whatever the shader specifies. And then the computer will also take those, triangulate them, and then it'll do a process called rasterization, which basically breaks it down into pixels. And then the second type of shader is a fragment shader, which colors these pixels in. And then once these pixels are colored in, it puts it to your screen. So that's the whole process of how shaders work in general. So very basic version of a shader. All it's doing is coloring an object. It's just taking those points, and then all the everything's blue. And then as you can see, that white dot is also part of the shader. It calculates the lights and stuff, and those specific pixels are white.
It's a highlight.
Yeah. Exactly. Now, another type of shader is a shader that just applies a texture to an object. These are more basic shaders. And then with these, you can also do moving textures without having to make multiple different textures. Or potentially you can mix the previous shader type with this shader type to get a shader that applies a texture as well as augments the color of the shader. The next type of, and these are all shaders we'll be making today, if you follow along. Next shader is called a Dither shader. What these do is, this is also a fragment shader, which is, again, the colors. As you can see, what it does is, what a Dither shader does is it chooses certain points, pixels, and instead of rendering them as they should be, it renders them as transparent, and you can see the pixels from behind the object. As you can see in this, it's got like a cool effect to it. The next kind of shader. Say that again?
Well, why does the example for a Dither shader look so pixelated?
Because that's what it's supposed to look like.
Yeah, that's what it does.
Mm-hmm. And you'll see that later in the thing. Specifically today, we'll be using the Dither shader to make a fading in and out effect on some objects, which looks rather cool in my opinion. The next type of shader is that we'll be covering today is what's called a Fresnel shader. If you're not familiar with that, the Fresnel effect is an effect where if you're looking straight on an object, it's not going to be reflective. Certain, obviously, like mirrors are different, but like you have a table. It's going to be shiny. It's not going to be shiny if you look straight at it, but if you look at it from an angle, it might be more reflective. And in this case, we're manually applying a
Math is
different
also
color.
weird, it is also weird because it's slightly reflective
Mhm.
when you look at it dead on, but glass is also different because when you look at it dead on, it's reflective, but when you look at it, it's somewhat reflective when you look at it dead on. I feel like it's either more or less dependent on the thickness when you look at it at an angle. Like
Yeah.
for glass.
That's part of the effect.
If it's not quite clear now, we'll see it later. It's better if shown on a square rather than a sphere, but when it comes to spheres, it makes it look like it's glowing, which is the use case for a lot of these. So then, going back to this again, all of those previous examples were examples of fragment shaders. So from this step to this step, sorry for the YouTube watchers, but it modifies the program and tells it to make the colors different than what it might normally do. Next type of shader is called a vertex shader. And the next kind of shader is a vertex shader, which takes those vertex points from the previous image on the left, and rather than sometimes keeping them where they are, we can sometimes move those vertexes to give the appearance of waves. That's one of the effects we'll be going through today, although it won't look as magical as this one. But anyway, that's the overview of shaders. Now let's actually get on to making the shaders. So to start, we'll be using Unity. And this will be a codeless tutorial, so it's very easy to follow along. I know shaders are very difficult to start because there's a lot of code. It's very complex and it's a lot of stuff. But fortunately, Unity has these very nice packages that allows you to make these shaders without having to do coding, which makes it fun, easy, and very rewarding because it doesn't really take all that much time, as you'll soon see. No, take your time, and I'll take a break every now and then. So when we create a project, we are going to have to do not the built-in render pipeline, but we're going to want to be using the universal 3D one, specifically the one that in the description it says universal render pipeline. So I don't think this is downloaded by default, although I don't think it's very large. So at this time, we'll let everybody download that and load up the project, because loading up the project is the longest
I'm
part.
still downloading the latest version of Unity.
But you can, yeah, whatever.
I don't think it really matters as long as it's one of the more later versions.
I have 3.111. Is that good?
That should be fine.
Yeah, as long, I don't know exactly, but I'm using 22.
I should make it big.
It shouldn't make a big difference, maybe just a few UI differences. But in the meantime, I'll let that go. And there is a few, if you would like to make your shaders a little more customized, take this time to download a few textures if you want. Specifically for this project, I'll be utilizing a water texture, which we'll be applying to our water. So
Should I show Unity?
is Unity done? Okay. Is everybody else project open? Okay.
Sounding maybe.
I'll take that as a yes unless I hear otherwise. Still loading?
Oof. I'm sorry, I'm just waiting for the thing to load up.
No, you're fine. It's
You go ahead.
Yeah, you can go ahead a little bit.
okay. So, if you are trying to make a shader, there's two ways to make a shader. Number one, you can do code. Code is not fun. I've tried it. Trust me, it's not fun. But like I said, Unity has this cool package that we can download called Shader Graph, which allows you to code, air quotes, without actually having to code. To install this, or to check to make sure it's installed, we can go to Windows, And then we can scroll down to Package Manager. This opens up the Unity Package Manager. And to see if we have a shader graph installed, we can go to the Packages, Unity Registry, which rather than searching our project, it searches all of the Unity packages. Look up shader graph. And then for me, it's already installed, so I'm not going to hit remove. But if it's not installed for you, you're going to want to install it, and that will allow us to do the next stuff. So, has everybody gotten to this point yet? We're just ready to go straight into shaders. All right, to start, we'll be doing the basic, easiest shader there is, and that's just a color shader. It's just going to change an object. So, for some Unity personal preferences, I like to always make a folder, name one shaders. Obviously, we'll put our shaders in there. And then we're also going to need a material folder, as shaders are something you can't just apply to an object. You have to create a material out of it first, and then you can apply the material to your object. So we are also going to use a material folder. Then, now let's make the shader. So, is everybody's Unity project loaded? I guess this is time for my dad jokes.
Yeah.
Where do dads store their information?
Cloud.
In
File.
the file cabinet.
Media share.
In their database. All right. All right. We're enough bind.
Yeah.
Let's get started, shall we? Let me sit down.
Okay, so it's Windows.
It is, once again, it is Windows, Package Manager, and then at the top left, you're going to want to switch the packages to Unity Registry. That way, if it's not in your project, you can add it to it.
Oh, I already had. French.
All right, so now let's make our first shader. So to make a shader, you just right-click, go to Create like any other Unity thing, and then over on towards the top, you see Shader Graph. Now there's two types of shader graphs, the URP and built-in. As you remember, we chose the URP, so we are going to use the URP version. It's a slightly more, it's a better shader graph. I don't know exactly the differences, but. So we will go with URP and then unlit shader graph. For this one, I'm going to call this one basic shader because it's going to be our very first, well, basic shader. And then once created, we can just simply double click on it and it opens up this window. Now, I think this window is very small, so I full screen it, especially since you won't need it. I mean, you won't need any other tab until you're done with the shader. So, as you remember, the vertex, there was two parts, vertex shaders and fragment shaders. As you can see, there's vertex and fragment. To change the position of vertexes, you would change these three values, and you would input stuff into here. For colors and textures, that's the fragment shader. So to make our very first ever shader, we're going to go here, go color. It is a variable type in Unity. It has an RGBA value, which the A stands for alpha, which is transparency. But, so we can take our color that I named color and simply put it into the fragment shader.
It's the my F1 so
Then save.
I'll just listen along.
Now, if you would like to set a default color for your shaders, this can be changed later as any value in this left-hand box can be changed within your Unity inspector, or code as well, if you have extra scripts to do fancy or other stuff. But for now, color, you can change the default color. Let's do red. And it gives you a preview of what it might look like. Obviously, you can hit Save Asset up here. Control S sometimes doesn't work, so I would always recommend Save Asset. And then now, let's put our shader on an object. So what are we going to need to do? We're going to need to create an object. I'm sure you guys are familiar with this, but in case you're not, right-click on the scene hierarchy, 3D object, and it doesn't really matter for this one since it's just color, but we'll do cube. I'm going to move it closer to the camera by simply using this, making sure it's in frame. And feel free to let me know if I'm going a little too fast for you, or if you need me to stop and catch you up. But for now, we've got our object and we've got our shader. But dragging our shaders to our object doesn't work. You see the X. So if you remember earlier, I said we have to take our shader and make it into a material, which we can then put on our object. So going to our material folder, we can right-click, create, and then material. I'm going to call this one basic material, as we are using the basic shader. Now, what this tells Unity is, the material tells Unity, that whole picture earlier is essentially the material. It tells Unity how to deal with the fragment shaders, vertex shaders, and all that stuff. So to apply the shader to our material, we simply click on the material we want to apply it to, and at the top right, you see shader. You simply choose the drop down, and we're going to choose shader graphs because that's what we're making. That's what we were making, and we can find our shader that we made, basic shader. Now, as you can see, we have the color, which is this variable here, which we can change to whatever we want. And the benefit of doing this is we can have the same shader apply to multiple objects. So say, for example, we want a green square and a red square to do, like from the same shader, you can do this. That's why we make it a variable. So now we can just simply drag and drop. Boom, your first shader. Now, it's not a very advanced shader. It's just a color. But we'll get on to some more advanced ones here. So moving on, let's go back to our basic shader and make it just a little more exciting. We'll be adding, well, let's add a texture. So what we're going to be doing is we're going to be going to this bar, click the plus, and then we're going to click texture 2D. This is a variable that takes in like a file that's a texture. So I'm just going to keep it as texture because who cares? So then we're going to drag our texture variable into our scene.
Oh my gosh. Loaded.
And then if you would like to set a default texture, you can do it here. I will set it to just the default black and white checkered thing. Now to actually apply the texture to our object, we are going to need a node, which you can create a node by doing one of two things. You can drag and drop into the open, or you can just right click, create node. And then you should be simply able to do sample texture 2D is the node we are going to be using. What this does is it takes our input picture and transforms it for Unity to then apply the textures to our object. Now for now, we could wire this straight out, and as you can see, it's just gonna apply the texture to the object. But say we want to take this texture and say give it a blue hue to it. What we can do to that is we can right-click this, delete, and then we can create a new node called multiply. What this does is, well, it multiplies the two inputs. Now, that might seem simple, but when it comes to colors and stuff, it's a little not what you might expect. At least it wasn't for me. What it does is it multiplies the RGB values of the texture with the color and outputs it like this. As you can see, the color was red, takes the texture, and now the texture is red, which is very helpful for some more, say for example you have a portal and you need multiple different colored portals. This is how you can do it. Now we can output it and then save. And then we can create material, and then again, shader graph, basic shader. Now we can apply it. Now the texture's on there. You can go down to the shader and change the color. Boom. Now, still very basic. But say for example we wanted to have our texture move, or say for example, if you've ever watched Chowder or something like that, where there's like the texture that's static as the object moves around. We can do that stuff with shaders as well. We're going to do this to this shader, and it's fairly simple to do. So if you come back to our shader, what we are going to do is we want it to scroll. So to scroll, we need to tell it what direction it needs to scroll. For this example, we're just going to tell it to scroll in two directions, the X direction and the Y direction. So we'll create a vector 2. I'm going to call this scroll speed. Now, just for reference, let's click on it, and then you can edit. If you click on node settings, you can see the properties of the variable. For us, let's say we want to scroll it one speed. The speed is, and then the Y will put 1 as well. So it should scroll bottom left to top right if we do this correctly. So what we're going to do is we're going to take our scroll speed, and then we're going to use a new node called time. What time does is there's a few different outputs here. Time 1 just simply gives you a number based on how long it's been running. That's good enough for what we need to do. We just want it to continually scroll. So we want to take these two things and multiply them together. What this will do, let's fix these wires. What this will do is it'll take the speed we want and scroll it over time. So this multiply scrolls over time. Awesome. Now, how do we actually make the texture scroll? What we need is a new node called tiling and offset. Once I finish, I can catch people up.
Thank you.
Okay. Because we're almost done with this one. Anyway, continuing. So what we're going to want to do is, in the sample texture 2D, this UV essentially means, I don't know what it stands for, but it's essentially kind of the offset, or how it applies the texture to the object. Yes.
I think U and V is just another variable name for like an X and a Y. I believe
Potentially. I honestly don't know.
I'm pretty sure that's what it stands for.
But what we can do is we can take this multiplied value, turn it into an offset using this tiling and offset. So now this whole chunk is giving us an offset. Now if we tell the texture, this is the offsets we want to use, you can see that in the main preview, we've got a scrolling texture. So now let's apply it to one of our objects. we can save asset. And just like all the other materials, this one already is working because it's using the same shader, the same graph. Now, boom, we've got a scrolling texture. And for now, it's just automatically going, but there's multiple different uses for this, as you can do. You can mix it, make it sync with the player's movement, a bunch of different things. But for now, that's the textures. Now let's move on to, now I'll make sure everybody's caught up, I should say. Is anybody still struggling, falling behind? All right, so now now if you remember, we've already done this, as you can see and remember. Now let's move on to the dithering effect, which is my favorite shader type. So what we're going to do is let's make an object first that we're going to put it on. I'm specifically going to choose a capsule because no particular reason. You can make it whatever shape you want. And then I'll move it closer to the camera for us. Yes?
Where can I find materials?
Materials is a folder that I created. So if you do not have that, you can simply go back to Assets,
Okay.
right click, create at the top, and at the very top, the next thing, folder.
Folder.
Now, it doesn't really matter the names or where you put these. It's just good practice to always keep your materials in a folder, your shaders in another folder. And if, now I won't be doing this, but if you have textures, a known specific file for that, folder. So now, moving on to the dithering effect, let's move back to our shader folder. Then we'll right click again, create, shader graph, URP, which is the one we're using, and then unlit shader graph again. Now I'm going to call this one dither effect so I can differentiate the shaders. All right. So, as you might know, as you might have realized, colors, the color variables, are RGBA, which is 4 values, while fragment is 3. For a dithering effect, as you may remember, I said we make some things transparent. So we have to enable that in our graph. To do this, we can simply go to the graph inspector in the top right. I'm going to expand it a little. And there's 2 things we're going to need to update. First off, we're going to need to go to surface type and then switch it from opaque, which means you can't see through it, to transparent, meaning transparent values are allowed. And then we are also going to click this box called alpha clipping. Alpha clipping is essentially a shader's way of saying, hey, if the alpha value is below a certain point, don't render it at all, which is something we need for this dithering effect, as some pixels aren't rendered. Now, to do this, it's actually quite simple. It's simpler than what you might think. So, to start off, let's get a texture on there. This is something that is very common with every shader. You're going to want to, once again, texture 2D, and that's from the plus on the left-hand side. Then you can name it whatever you want. I'll name it base texture. Then from here, base texture, we're going to link it to a sample texture 2D. Again, that takes the image, turns it into a texture that Unity can use. Now, instead of wiring that to the output, let's do the color and multiply it as well. Now, if you'd like to move multiple things, you can simply hover over it and move it. So what this does is similar to the previous one. Once again, takes a texture and modifies it by the given color. For now, I'll just choose the base texture again. Then, now that we have this multiply, as you can see, as I mentioned earlier, this outputs a four values, but color only has 3. And we have alpha here that we want to put something in. So to get these values, we can't just simply do this, because then shader graph ignores the 4th one. Now we do need to do that so it accepts the red, green, and blue values. But to get the alpha value, we simply create another node and then type in split. What this does is it takes any input we give it and makes it to where we can access any individual one. From here, we'll take this alpha value and put it into our alpha. Fairly simple. And then for the hardest part, be scared. To add the dithering effect, we simply just create new node, dither.
Jump scare!
Whoa.
Don't sneak up on me like that.
You gotta put dinner jump scare in the video. Okay.
Now, you see this and it's like, well, what is this? If we set this x value to 1, this is a commonly known dither pattern, which if you look in, you can see this pattern. This is the pattern we want to apply to our texture. So to do this, all we have to do is take this out and put it into alpha clipping threshold. And then there's one last thing I would like to do for this, just to show how awesome this effect can be. If you would like, this works as is. You can save it and you can apply it as material to an object. But I'm going to make it to where it fades in and out, which is a very great use for dithering effects. As dither, when the alpha value gets smaller, it looks like it's fading away. So to make it change over time, we simply need to create a new node and put in time. Now we take our time and our split, and we need to link them into a multiply node. If you haven't noticed already, multiply is a very, very helpful node in a lot of shaders. So to make it change over time, we are specifically going to use sine time, which I won't go into the details of why that is, but it essentially will make it to where it'll fluctuate. Then we take this alpha and put it into this multiply as well. Get rid of this line. And then now instead of directly alpha to the alpha, we'll take this multiply to the alpha. So now it's time to save. And then we'll go back and then do what we did with every other shader we've done so far. We're going to create material. I'm going to call this dither because that's the effect we're going to use. And then at the top right, once again, we're going to shader graph and then choose the shader graph you named. Mine was called dither effect, so I'm going to choose dither effect. And I'm going to give it a base color of yellow because I'm crazy like that.
Whoa! What?
Has everybody gotten to this point where they have the shader saved and it's in the correct set? All right. So now we can go back to our scene. We can take our dither effect and apply it. Now, you might have already seen a sneak peek, but if you hit play, you'll see it in better quality. Voila! We've now got an object that goes in and out. And as you can see, it's a very nice effect. The dither effect makes it very cool. And if you would like to see the dither effect in more action, what we can do is we can put an object behind it play. And then you should be able to see the object as it's going in and out, which is something that's very unique to these. That's, I like it. Yes.
I'm kind of having trouble with, trying to find a material.
Yes.
Is it okay if you show me how to do it a little bit?
Absolutely.
So like create material. Okay. And then I'll put a new one. And then at the top here, we can like that shader wrap. And then choose whatever the shader wrap you have that we just made.
Let's just move it all the way over. Alright. Yeah, I need to.
No, for these first. Or I can also upload the shader graphs. Or if you'd like as well.
Thank you. I'm sorry.
No.
I did this before. I played this games before.
No worries, no worries. So now let's move on to our next shader, which is going to be that Fresnel effect that we saw earlier, where it's with the sphere that looks like it's glowing or radiating like a light from it. So this one's fairly simple as well when compared to like the Dithering Shader. So what we need to do for this one is, once again, a lot of these steps are going to be the same. We'll leave play mode. We'll go to our shader graph. And then once again, shader graph, URP. This one specifically needs to be a lit shader graph though, because it applies a light, which is that effect. So we need the lit shader, and then we're gonna call this, I'm just gonna call this Ethan is cool because I am. So, if you are not seeing 6 things in your fragment thing, we are, oh, I lied. I'm sorry guys, I lied to you. You do not need a lit shader for that. But a lit one will make it easy if you like. I mean, you can still do it with a lit shader. So just to prove a point, we'll do it with this lit shader. To apply the Fresnel effect, once again, similar to the Dither effect, Unity's coming in clutch. Shader graph has its own node for Fresnel effect, and you can follow along, Garen, at this point, right? So right click, and then we'll create a node, and then we're going to look for now, which is not, it's Fresnel is how it's spelled, so make sure you find the right one.
Fresnel effect?
Yes, Fresnel effect, and then when it comes in, you should see the effect that we want to apply to our object. Now, for ease of access and just niceness, we're going to create a float variable, and then I'm going to call this power. Now, if you don't see where this is going, we're going to simply take our power and link it into the Fresnel power.
So wait, it's, you go into basic shader, you press which one? Keyword?
So how I got this variable is I simply just clicked this plus button right here,
Yeah.
and then chose float, and then named it whatever I wanted.
Okay, so power.
Now, again, for some ease, what we're going to do is we're going to click on our variable, and then in the graph inspector, you should see it now selects node settings. So this is how we can change the properties of power. For example, for this specific variable, we're going to want to set the mode, which should be set at default. We're going to set it to slider. This is going to allow us to tweak this effect within the Unity scene. For now, we're going to set the default value to 1. That is a very average value for the Fresnel effect. And then for the max min, I do 0 to 20 for this effect, but I don't really know what's optimal. You can feel free to play around with it. So that's all we have to do. And this is technically not this is not a necessary step. It's just a step that helps production along. So from here, we can take this Fresnel effect and say we don't want this white glow, but instead we want a green glow. Well, similar to the textures, we're just going to go to the plus. We're going to go to the color. We're going to name it whatever we want. I'm going to call it color because I can. Then simply we take the color and once again multiply with the Fresnel effect, and you should see, yes.
How do you get that for that effect right there? Is it just like left click again?
This Fresnel box right here,
Oh,
Yeah.
one,
or this one.
that one.
Okay, so there's 2 ways. Number 1, you can drag and drop a wire not into anything. Or the easier way is just simply right-clicking and then create node, pulls up this menu, and then we simply just type in multiply. And it's fairly smart about giving us the one we want.
Okay.
And then you can simply hit enter, and it'll put it into your scene. And then, once again, if we want a texture on it, simply texture 2D. I'm just going to keep it base name. Drag that into our scene. Create node. Sample texture 2D. And then we can do what we did with the other ones, apply the texture. And then, unlike the other ones where we multiplied to add it to the texture, this one we just need to add the Fresnel effect. So to do this, let me rephrase. Does everybody have the texture in their scene?
Okay.
So going back, we have this texture, which again is we just made a texture variable and then put it into a node called sample texture 2D, which is, then now we can create node, add, and then we'll pipe in our texture and then our color. Now, I'm going to set the default color to something not black so we can see. Let's do green. So, if yours isn't updating in time, that's fine. As long as the connections are the same, it should work properly. Now, again, I'm going to also put a texture on so it's not a white blob. We'll just do the default checker because it's there and it's easy. So now we have our Fresnel effect, and all we need to do is just output it to the base color. Save asset, and that's our shader done. Anybody have any questions? Now, so as you can see, we'll do what we did with every other object again. Material, right click, create. Material, we'll name it for now, even though it's misspelled. We'll go up to the top, we'll select the shader we just made from our shader graph section, which I named Ethan is cool. Now you can see also the textures, the color, and the power, which are all the 3 variables we had over here, which is, again, what we needed. So now I'm going to create an object to apply this to. I'm going to do a sphere because spheres are the easiest to see this on. And then we'll put it in the middle of our scene, which I will also move these objects out of the way. And then simply take our Fresnel effect, and then boom, now we have it on our object. Again, if we go to the thing, we can increase the power, which makes unintuitively lowers the glow. But the lower the power, the more glowy it is. Now, say for example, if you can see some of the pixels outside of the actual thing are appearing green. That's what's called bloom. And if your project is not showing this, there's a simple solution to do this. You simply need to go to global volume, which if is not an object in yours, it means you are in the basic rendering pipeline, which does not have, which has bloom capability, but it's there's some hoops you have to jump through to get that to work. But if you are able to get, if you are able to go game object, it's somewhere within the game object you can find a global volume. Now, if you see bloom, perfect. That means bloom is enabled. If bloom is not enabled, you can go to add overwrite, search for bloom here. Obviously, it's not showing because I already have it added, but you can simply just add it as one of the post-processing things. Now, as you can see, if we turn off bloom, it makes a significant difference to how glowy our sphere actually is. So that is the Fresnel shader. Now for our very last shader for today, I will do what's the first type of shader, which is a vertex shader. So instead of changing the appearance or the pixels and the colors of that, we're going to be changing the position of some of the vertexes of the models. So if you didn't know, you can go into Unity, click this button up here in wireframe mode, and you can see all of these pixels. So at the intersection is going to be a vertex, and we're going to be moving those. Now moving back, we're going to be making water. So what do we need? What looks the best for water? I think a plane. So for this, I'm going to create 3D and add a plane. I'm going to reset it so it's in the middle, and then we'll move it closer to our camera. Now, once again, this is going to be something you always got to remember. Shaders, right click, create, shader graph, URP, and then vertex shaders do not need to be lit, so we're good to do unlit shader graph. And then we're going to call this one waves because we're going to be applying waves. Now, let's open up our shader graph. We do not need to mess with the graph inspector for this. And, all right, let's get started. So, for our waves, what we need to do is we need to first set up variables that describe the way the waves move throughout the scene. So we can do this by first creating a speed variable. Simply the plus button, float, and speed. This will determine how fast the waves actually move. And obviously we want it to move over time. We don't want it to just repeat. We don't want it just to do once, so we're going to have to create node, and then we're going to use the time node, so it changes over time. I'll move over here to give us a little more working space. So we'll take our speed value and our time value, and can you guess what we're going to do? We're going to multiply them together. So this is giving us a value that's just continually getting larger, which is good for waves. It's it continually moves in the same direction. Then we're obviously speed. And then for this one, we'll just use normal time as well. Then what we need to do is we need to set up a way for the object to know where it is in comparison with these waves we're sending out. So what we need to do is we need to create a new node. This one's different. This one's called position. So what this does is this tells Unity where the object is within the world or the view or the tangent. We're going to keep it on world for this. And then we're going to take this and then we're going to split it. So we want the wave to only move along the x and the z. We don't want it to move up. We just want it to move horizontally across our scene. So we are only going to, we're going to input the position, and then what we're going to do is we're going to take these splitted values and we're going to add two of them together. Now, you might be confused. I see RGBA, but obviously we're not working with a color here. But how Unity interprets it is X, Y, and Z. So we're going to take the R, which is X, and the B, which is the Z, and add those two together. So this now tells us how far the waves will be in comparison to the object and how it needs to react. So what we can do now is we can take this value, these two values we have, and add them together. This just combines them to give us tells the shader we work properly. Now, at this point, it's only going to send out one wave. But we want multiple waves because oceans don't just send out one giant wave unless it's a tsunami, which isn't accurate. So for this, we're going to enlist the help of the best math function, the sin or sine. And if you are not familiar, this gives you a value between -1 and 1. This gives us the oscillating pattern that the waves will take, as waves normally look like sine waves. Okay, so now we have our waves. They're getting sent out. But say, for example, we want to change how high the waves are or how shallow they are. We may be baby waves, or we may have monstrous waves. So we can do that by adding a new variable. Once again, a float. And then we're going to name this strength. This is going to represent how strong the waves are, how big they are. Now we can multiply, so right now we have our wave. We can multiply that with our strength value that we just made. And then we now have, although it doesn't show because Unity's dumb and sometimes it likes to update in real time and sometimes it doesn't. I know I've done a lot. I just want to make sure, is everybody at this point? Or does anybody need me to zoom in so they can see a little better?
What's the second input for the multiply, the bottom one?
It is speed. It is just it is the speed at which we want the waves to move.
Should I set that at 1 initially
Uh,
to do something?
good thing. Yes, we will set it to 1 for now.
Whoa, it's doing a thing.
Yes.
Oh, wow. It's a wave.
So as you can see, it's continually sending waves over time. So now, our strength value is set at 0 too. Let's just set it to 1 by default now. So now we've got waves that are the same value. But to then apply these to the vectors, we need to do, for waves, what direction do we need to send the vertexes to make it look like a wave. Well, we need to modify the up and down value, which in this is the y value. So we can simply take a vector node. This one we need to do through create node. And then we'll do vector 3. And then we've got our x, y, and z. Now we're going to take this wave, and then we're going to now tell it to move however many units up or down. And then we need to give it the relative position of the vertexes to start with. So we will create a new node, position. But this time, instead of world, we want object. So this is going to say, where's our relative position compared to the center of the object? Now, we can simply add these two together. So, say for example, it's at 1, 1. The wave is telling us to move it up 1 unit. You add those two values, 1 plus 1 is 2. It's now up. Now, as you can see, it should give you a weird little shape. Now that's all we need to do for the vertex shaders. But since we're not messing with the colors, we're simply going to pipe this into the position, which is a vertex shader. So now, although it's hidden, if you've done it right, you should now see that the wave effect applying to this material in the preview. And then just for some niceness, I'm going to do what I did with all the other ones. Create a texture. I'm going to pipe it into a sample texture. Oop. And then we'll put it into our fragment shader. And then just for simplicity, I will set the default texture to this. And then that's all the shader is. So now we just save it. And then with all the other ones, we need to create a material. Once again, shader graph and waves. So now we can apply it. Then you should see waves within your scene. As you can see, we've got a wave. Now, once again, if I didn't say this earlier, I'm saying it now. It won't look smooth just normally. To make it look smooth and how it would actually look in a game, there's two things you would want to do. Number one, play it so it plays. And then, as you can see, there's a lot of triangulation in this one. I specifically took a low poly plane to show you that when it comes to some shader effects, the mesh does matter. For this one specifically, there's not many vertexes, so it looks very jagged. So to make it look better, which we won't be doing in this thing, you would just need to simply get a more detailed mesh, which refer to our Blender workshop, and you should be able to get there. So now, just because I like my water to actually look like water, I'm just going to give it a texture. So I'm going to actually drag in a texture. If I can find it, in preparation, downloaded a water texture. Here we go. Now, if you're a seasoned gamer, I'm just going to put it in the material just so it's easier. Now we've got the Wind Waker water on our wave. So, perfect. One more thing I would like to mention is I'd like to go back to this and explain why we chose world here. So what world is doing is it's comparing it to where it is in the world space. What this allows us to do is I will play just so it continually is smooth. And I'll go back to scene while it's still playing. What this allows is the waves are within the world, not specific to this texture or this shape. So what this means is when we move it across the world space, it'll follow those invisible waves that we have. Which means if you want to add more waves, you can simply take your plane, duplicate it, and then extend your wave, just like that. Now, let me show you what happens if you don't have that as world.
I think that you'll also just scale off the plane.
You could, but I mean, if it like, there's use cases for both having it world and object here. Now, if you go back, you can see now they're not, if you just have it based on the object, they don't line up. Which is why I specifically, for this example, chose the world, not view. You know what, just out of curiosity, I don't know what this will look like. Ooh.
Ooh, magic carpet. Wow.
So that is how you could do some effects. That is very cool.
It's really wobbly. It's got the wiggly palms. It does.
So yes, that is the last shader I have prepped.
I think it looks cool.
I would like to show just a little flex, if you guys don't mind.
Oh yeah, well, the world's not.
Uh,
You're not ready. The world's not ready for that. The world's gonna leave behind.
I open up this project. I was messing around with some shaders and following some tutorials on YouTube just because I wanted to show something also really cool, because shaders, you might not notice, you might not even realize that shaders are there. So,
They do a lot.
because some games you might, like old games, does Mario 64 have shaders? You might immediately say no, but it does. And once this project loads, you can see that I recreated, with the help of YouTube, so I'm not taking full credit on this one. With the help of YouTube, I recreated the Mario painting effect, which shows that all the use cases for shaders. And while that loads up, I can hand it back over to you, Wyatt, and finish up, because it's just gonna, that's everything I got.
All right, well, just some reminders real quick. So we'll, of course, have a meeting next week. We'll be doing a sort of a new thing we're trying out, Adam and I. It's going to be a case study. We're going to be looking into some games, talking about some like sort of good design choices, stuff like that. So it should be fun. I suggest everyone, of course, comes as usual. In the Game Jam, once again, April 11th. I, again, strongly encourage everyone to swing by. It should be a fun time. So you don't need a team going into it. You can find some people there, make a team, come up with some cool games. So game night also this Friday, 7 to 11-ish. I mean, it's usually like just depending on how long people really want to stick around, but starts at 7. Actually, I'm curious. What's the winning game right now?
Yo, I love Jack Black.
Let's see.
Jack Black?
Flint and Steel.
Currently,
Nice.
oh, that's the voice chat. Currently, it looks like
Minecraft.
it looks like Minecraft is winning by a significant margin. So
Not a
yeah.
very significant margin. It's 5 votes. It's only 5 votes ahead of Terraria.
That is still a significant amount relative to the number of votes. So
Yeah.
anyway, yeah, game night probably gonna be Minecraft. So yeah, if you're also just here, can you guys just let me finish up real quick? Okay. So but yeah, game night again. Also, if you're interested in paying dues or haven't already, Ethan's here as obvious.
As a reminder, you need to pay your dues if you would like to win prizes from the Game Jam. You can still participate even though you don't pay your dues, but you won't be eligible for the cash, well, the prizes.
Right, because we use dues to help pay for like club stuff, so like shirts, the game jam, prizes, stuff like that. So, anywho, that's all I have. So go forth, make games, be awesome, everyone. So.
Well, now hopefully it's loaded.
Hopefully.
Oh, yeah, let's go. So I have some prep. Ooh. Ooh. Now let's.
Oh yeah, yeah.
And then if I go here, and actually change it to the Mario portal.
Oh, that's.
Why does it do
that's
that?
sick. That's
You need
sick.
to rotate it.
I don't know why it didn't.
Well, no, I mean that the texture is.
I did.
I thought.
I don't know why. Okay, well, feel free to.
Reference.
Reference.
Woo.
Oh my gosh, it's
Mario
fun.
64.
I can finally acknowledge it's good.
And if you would like to know how to do that,
Mario 64's controls kind of suck. I'm gonna be honest, even with the N64.
Yeah.
as you can see, it's a lot of.
We're not recording.
It's similar to the other section where we send out waves, but instead we're sending out from the center, the speed obviously, and then we multiply it by the wave counts and some other stuff. We use this 1 minus to make sure it's going out from the center. If you'd like, I will put all of these shader graphs from today's workshop into the Discord, so you can follow along and recreate them at home. And I will put this one in there as well.
Sweet.
Awesome.
Yep.
Thank you guys.
Yeah.
Not a bit.
You just like screamed on my.
LeBron, scream if you love the GDC.
LeBron James.